In section 14-4, we're going to look at surface area. Students will be able to understand and explain surface areas of right prisms, right circular cylinders, right regular pyramids, right circular cones, and spheres. Lateral area is defined as the sum of the areas of the lateral faces. Surface area is the sum of the lateral surface areas and the area of the bases. Let's consider the surface area of a cube. We know that a cube has 6 faces and each of the sides has the same length. So let's suppose we have a length of E. So the area of one face is just E times E, or E squared. Now, if I look at the cube unfolded, each of the faces has an area of E squared, and there are 6 faces. So we know that the surface area of a cube is going to be 6E squared, and E is the length of one of its sides. To find the surface area of a right pentagonal prism, we're going to unfold the pentagonal prism into this figure on the right. We have a pentagon and another pentagon here for the bottom, and we have 1, 2, 3, 4, 5 rectangles. The formula to calculate the surface area is given by P times H plus 2B, where P is equal to the perimeter of the base, H is the height of the prism, and B is the area of the base. Now, why is this formula true? Well, if you look at the rectangles here on the bottom, the rectangles will have a total length of P. The reason they have a total length of P is they are the perimeter of the pentagon. So this distance is a distance of P, and this has a height of H. So the area of these rectangles here is just the perimeter times the height. That's where the pH comes from. The B is just the area of the bottom and the top. So that's why there's 2 of them, because we are adding the 2 areas together. So you really don't have to remember the formula, you just have to add up all of the surface areas individually and you will still get the right answer. Example, let's find the surface area of the prism. Here we have a triangular right prism, and we're going to find the surface area. Now remember, the formula for surface area is given as surface area equals the perimeter times the height plus 2 times the base. So we'll look for the perimeter of the triangle first, and we know the perimeter is just the sum of all the sides. So P is equal to 3 plus 4 plus 5. So we know the perimeter is going to be 12 centimeters. Now the height is 10, so I know H equals 10. And the area of the base is given by the area of a triangle. So we know B is going to be equal to 1/2 base times height. And in this case, we have 1/2. The base is 3, and the height is 4. 1/2 times 3 times 4 gives us 6 centimeters squared. So we know that the base is an area of 6 centimeters squared. So the surface area of our prism is going to be 12 times 10 plus 2 times 6. And this gives us 120 plus 12, or 132 centimeters squared. So the surface area of this figure is 132 centimeters squared. Now, if we go to the simpler case, the right regular prisms, it's pretty easy. We just add the top, the bottom, and the lateral faces around. Well, for a right circular cylinder, the idea is the same. We'll have to find the area of the bottom, the area of the top, and then the area around the cylinder. And that's how we calculate the area. To find the surface area of a right circular cylinder, we're going to unfold the cylinder. We know on the top we have a circle with radius r, and on the bottom we have the same image. We have a circle with a radius of r, and you can tell that the circular cylinder is wrapped by a rectangle. So this rectangle has a height of h, and the length of this rectangle is going to be the circumference of the rectangle. Recall the circumference is 2 pi r. So to calculate the surface area, we're going to take the area of a circle, which we know is pi r squared, and we're going to multiply it by 2 because we have a top and a bottom. That's where the formula has 2 pi r squared. That's the area of a circle times 2 for the top and bottom. The area of the rectangle is the height times the circumference. That's where the 2 pi rh comes from. So the surface area of a right circular cylinder is equal to 2 pi r squared plus 2 pi rh. And now we can easily calculate the surface area. All we need to do is figure out what r is and what h is in the problem. And then we'll plug it into the formula. Let's look at the surface area of a pyramid. Suppose we have a right pyramid with a square base, and the base has a length of b. Now to find the surface area, we have unfolded the pyramid here on the right, and we know the base has to have an area of b squared because the length and width is b. Now we have 4 triangles here, and each of the triangles has a height of L and a base of b. So the area of one of these triangles is 1/2 base times L, since L is the height. Now, since there are 1, 2, 3, 4 triangles, we can come up with the surface area formula as b squared for the bottom, and we're going to add 4 times 1/2 b times L for the area of each triangle. And the surface area formula simplifies to b squared plus 2bl. Now this is the surface area formula for a right prism with 4 faces. Now this is the formula that works for a pyramid that has 4 faces. Now we're going to extend this formula to something with multiple faces. So let's consider the surface area of a pyramid for any type of pyramid. Let's consider a right rectangular pyramid. The surface area is equal to n times 1/2 bl plus b, where n is the number of faces, l is the slant height, and b is the area of the base. This is a more general formula because we have n is the number of faces, and b is going to be the area of the base, and the base does not necessarily have to be a rectangle or a square. It could be a different polygon. The formula for the surface area of a right regular pyramid can be simplified because n times b is the perimeter p of the base. The surface area formula is equal to 1/2 the perimeter times the slant height L plus b, the area of the base. Example, find the surface area of the pyramid. Recall the formula for surface area is equal to 1/2 the perimeter times the slant height plus the area of the base. So we'll start with the perimeter. We have the distance around the bottom here is 4 plus 4 plus 4 plus 4, so the perimeter is 16 centimeters. The slant height is 5, so L is 5. The area of the base, since we're talking about a square, is going to be 4 times 4, or 16 centimeters squared. So let's plug in everything into the formula. So the surface area is equal to 1/2 16 times 5 plus 16. This simplifies to 40 plus 16, so we get the surface area is 56 square centimeters. To find the surface area of a cone, we're going to look at the pyramids and transition to a cone by creating more and more faces. To find the surface area of the cone, we're going to add the area around the surface, and then we're going to add the area of the base. The surface area of a cone is given by pi r squared plus pi r times L. Pi r squared is the area of the base, and pi rl is the area around the top of the cone. Here we have r is the radius of the cone, and L is the slant height. Let's look at the surface area of a cone. Recall the surface area of a cone is equal to pi r squared, the area of the base, plus pi rl, which is the area of the top of the cone. Now, we know the radius in this case is 3 centimeters, and the slant height here is 5 centimeters, and the height of 4 centimeters is not necessary for the problem. The surface area is equal to pi times 3 centimeters squared plus pi times, again, 3 times the slant height, which is 5. So the surface area is equal to pi times 9 plus pi times 15, and that simplifies to just 24 pi. So the surface area is 24 pi centimeters squared. The surface area of a sphere is given by 4 pi r squared. To calculate the surface area, all we need is the radius. So let's suppose the radius in our example is of 10 centimeters. So we'll calculate the surface area by using the formula, and that gives us 4 pi, and since our radius is 10, we'll plug in a 10 and then square it. So the surface area is equal to 4 pi times 10 squared is 100. So this simplifies to 400 pi, and our units is centimeters squared. So that's our surface area of this circle. Something interesting that you might not have noticed, recall that the area of a circle is pi r squared. Now, the area of this circle inside the sphere is pi r squared, and the surface area is 4 pi r squared. So if you look at the great circle, which is the circle inside the sphere, it will take exactly 4 of these to cover the entire surface of the sphere. Very interesting indeed.